Alright, so we are jumping into section 5.3. We are going to look at multiplication of polynomials. I'm sure this is everybody's favorite topic. Well, it's one of my favorites. But yeah, I mean, let's just jump into it. And I really want to reiterate as much as I possibly can that this is a piece of material or content that will show up a lot. Okay? It will show up a lot. It's going to show up a lot in this class moving forward. It's going to show up quite a bit in college algebra if you have to go take that class. It's all over the place in any future math classes if you have to do calculus as well. So this is just a huge, super important topic in all of that content. So that being said, let's look at a couple of examples. Now, I'm going to go through a bunch of examples here that you'll see that are similar to homework assignments or homework questions, but what I want to do is just point out just some of the features of these problems that I put together. So the first is just a multiplication. You've got a trinomial times a binomial. Trinomial means it has 3 terms in it, and then a binomial means it has 2 terms. So we have a trinomial times a binomial. And what we need to do in cases like this is we take every single piece and combination possible here between all 3 of these items and all 2 of these items. So if you think about all the combinations, there's going to be 6 total terms. 3 times 2 is 6, therefore that's what we have. In fact, that's pretty much how it works out in this case. If you have a 3 times a 3, then you have 9 possible pieces, or, well, you'll see here as we go down. So what we're doing is we're taking combinations of every single piece. So let's first start with 3x squared. We multiply it by 2x. We're actually going to go back to that 3x squared and then multiply it by the second term in that second piece, which is 3. Now, once we've done all of the combinations of 3x squared, we move on to minus 4x. So we have minus 4x times the first piece, minus 4x times the second piece, and now that we've done that, we jump onto the third term in the first piece. So minus 2 times 2x, which is right there, and then a minus 2 times the last piece right there. Okay? This is the easiest way that I can describe it to you. Otherwise, it's just really complicated and messy. You're taking every possible combination and multiplying. Okay? That's basically all you have to think about. So, take a look at what we get. When we multiply all these pieces out, this right here, we have a 3 times a 2, an x squared times an x, which means that I have an x to the third, because remember, I'm adding the exponents together. X squared times x is x to the 2 plus 1, which is x to the third. The 2 times the 3 is going to multiply to give me 6. Over here, same idea. I've got 3x squared times 3. The 3's are just going to multiply, and I've got a 9. X squared, again, there's nothing over here, so it's just x squared. It's following along for the ride. Minus 4 times 2 is minus 8. The x's, I have an x times an x, which is an x to the first times an x to the first. So x to the 1 plus 1 is equal to 2. Minus 12x, again, you can multiply the rest of these out, and this is what you're going to get. When you get down to this piece right here, to this form, you can combine certain terms. So notice how I've got a 9x squared minus 8x squared. They have the same variable and exponent connected, so that means I can combine the coefficients. So 9 minus 8 is going to be a 1. Same thing here, a minus 12 minus 4 is equal to a minus 16. The x comes along for the ride, and then lastly, my minus 6 is going to be just the minus 6. Okay? So that's basically and it's weird, you're probably wondering, why are you showing us something with 3 terms times something with 2 terms before you show us something with 2 terms times something else with 2 terms? Well, FOIL is one of those things that we are going to talk about. The FOIL method, it's kind of a mnemonic. It's a way for us to determine the order of multiplication and adding when we are looking at something that has a binomial times a binomial. In other words, something with two terms times something else with two terms. So, for example, I have x minus 7 times x plus 3. When I multiply them all out, I'm actually taking the first, so I'm using FOIL, first, outside, inside, last. FOIL first, so the x's, the outside, x times 3, the inside, minus 7 times x, and the outside, or the last, so minus 7 times a positive 3. So when you do that, you work it all out, and then you multiply, you get x squared. Here you get 3x. Here you get minus 7x, and then here you get minus 21. Okay? So we're just simplifying this piece up here. Then, when you combine your like terms, by the way, when you do FOIL, your middle terms are going to be the only ones that are like terms. I shouldn't say will always, but for the most part, they will generally be the same, and you can combine them. So now a minus 7 plus 3 is going to mean I get a minus 4. Down below, these are just special cases of sum and difference of two terms. So if I have, say for example, a plus b and a minus b, you notice how they're pretty much the same. The only difference is that the sign here is changed. You are going to get a squared minus b squared. In other words, it's just going to be this term squared and this term squared. So a squared minus whatever b squared is. I show you an example here. You can see square of a binomial. So again, these are a couple of special cases that I work out. We're going to go through a couple of examples, but again, I just wanted to draw your attention to the notes to go ahead and take a look at how all of that stuff works. Okay, I need to take a big deep breath because I am out of breath. Let's go ahead and jump into some problems. Give me just a second. Boom, here we go. All right, so question 5, or section 5.3, question 12. Again, all of these notes I've posted on Canvas. You can find them at the bottom of the homepage. So don't forget, in case you're like, you want to have like physical copies of these notes, not only the notes that I just went through, but also the problems that I'm working through as well. You can actually see them there all fully worked out. 4y minus 6y squared. Okay. So what I'm going to do is I am going to distribute that minus 4y squared to each piece. So in other words, this becomes minus 4y squared times 4y plus minus 4y squared times a minus 6y squared. Okay? So this times this plus this times this. And now I can go ahead and use the properties of exponents that we talked about the last time. I can do minus 4 times 4, which is a minus 16. A y squared times a y is going to be a y to the third. Over here, I've got a minus 4 times a minus 6, which is going to be a positive 24. I have y squared times y squared, which is going to be y to the fourth. I'm adding those exponents together. Okay, so this right here is our final answer. All right, let's look at question 16. I think I got enough room here. X minus 2x times x minus 2. So let's bring the x along, and now I'm going to do the exact same thing. I distribute this minus 2x times each individual piece. X minus, or actually let's just do this, minus 2x times x plus a minus 2x times a minus 2. Sorry, I'm running out of space there. So this is equal to x minus 2x times x is going to be a minus 2 times x squared. Minus 2x times a minus 2 is a positive 4x. Now, when we get to this point, take a look. This right here and this right here are like terms. I can actually combine them together. I can add them. So this means that I have 1x plus 4x. That will be 5x. And then over here I've got minus 2x squared. This is going to be just minus 2x squared. I don't have to do anything to it. And that is your final answer. Okay? All right, let's go ahead and keep moving along. Question number 20. 4b times 3b cubed minus 12b squared minus 6. This is equal to, now let's do the distribution again. This is going to multiply times each individual piece. Okay? So we'll have 4b times 3b cubed plus 4b times a minus 12b plus 4b times a minus 6. So now let's work on our multiplication. 4 times 3, this is going to be 12. B times b to the third, remember I add the exponents together, so 3 plus 1 is going to be to the fourth. 4 times a minus 12 is going to be a minus 48. B times b is going to be b squared. You can think of just b as b to the first. This is b to the first, so I add the exponents and I get 2. And now this is going to be 4b times a minus 6, which is going to be a minus 4 times 6, or 4 times minus 6, I should say, which is 24. A minus 24, and then b is going to be all by itself. So that right there is our final answer. I think I'm going to need some space on this next one, so I'm going to go ahead and erase this. All right, 24 minus 2y to the third times 3 minus 2y minus 3y squared plus 2y to the third. Okay? And so, like I said before, we're going to distribute this to every single piece. Okay? So in this case, there's 4. So we have a minus 2y to the third times 3 plus a minus 2y to the third times minus 2y plus a minus 2y to the third. I think I'm going to run out of room here. Minus, there's a minus in front there, times a minus 3y squared plus a minus 2y to the third times a positive 2y to the third. Okay, sorry, I'm running out of space. All right, and now, so this is the whole distributed thing. That's crazy. That's crazy. All right, minus 2 times 3 is going to be a minus 6. There's only a y cubed there, so that's all we care about. Then we have, let's see, minus 2 times a minus 2 is going to be a plus 4. So you can kind of see I'm working each thing separately. I write it all out, then I do the numbers multiplied by each other, and then I take care of the variables. So minus 2 times a minus 2 is a positive 4. Y to the third, y to the first. Again, you can think of that as y to the first. I'm going to add those exponents. So 3 plus 1 is 4. So this is y to the fourth. Minus 2 times a minus 3 is going to be a positive 6. Y to the third, y to the 2. I add the exponents, y to the fifth. Minus 2 times 2, minus 4. Y to the third is y to the sixth. Not ninth. You are not multiplying 3 times 3. You are adding. Remember, all of these are multiplying, which means y to the third plus times y to the third means y to the 3 plus 3, which is 6, not 9. Okay. Generally, when we represent these, okay, we usually put them in order from the highest exponent down to the lowest exponent. So all I'm going to do is just shift the order of these. So I get minus 4 y to the sixth plus 6 y to the fifth plus 4 y to the fourth minus 6 y to the third. Okay, and that is going to be my final answer. Again, both of these are technically correct. There's no difference really. The only difference, again, is the way that we normally write them is to have the exponent, the highest exponent, first, followed by all the other ones in order. Okay, let's go through a few more. Let me do one of those trinomials versus binomials times a binomial so you can kind of see how that one works. My whiteboard is getting kind of nasty. I gotta clean this thing off. All right, 42. 4x squared. Whoa, that's a terrible 2. Let's redo that one. Whoop, there goes my camera. Hang on. Hang on. It was early this time. I haven't even gotten 30 minutes in. All right, hang on just a second. I think my program crashed. Okay, so we're back. Here we've got 4x squared plus 3x plus 1 times 6x minus 6. Okay, so these are going to be, again, these are a little long, so it's good to maybe do this with a pencil. I generally do mine with a pen because I like seeing my mistakes. It's just the way I work, but if you are likely to make a lot of mistakes, it's probably best to have a pencil here in this case. All right, so what we're going to do is we're going to take the first term of this guy and multiply by each piece. Then we're going to move on to the second term, do the same thing. Then we're going to move on to the third term and do the same thing. Okay, so in the end, there should be 6 total terms, right? 3 terms here, 2 terms there. That makes 6 total terms. So let's go ahead and do it. I'm going to need as much space as I can. 4x squared times 6x. Okay, the first. This one times that. Boom, done. Plus 4x squared times minus 6. Now we're done with the first term. Okay, since we already did both those pieces, we move on to the second one. Plus 3x times 6x. Plus 3x times a minus 6. I'm still going to run out of space probably. Okay, so now that we're done with that, again, we're done with that guy. We're going to move on to the final one, which is the 1. So plus 1 times 6x plus 1 times minus 6. Okay? So when you get done with this, you can count. Make sure you have enough. 1, 2, 3, 4, 5, 6. Okay? I think I'm good. And now we do exactly what we just did before. So 4 times 6 is equal to 24. X squared times x is going to be x to the third. 4 times minus 6 is going to be a minus 24. X squared, there's no x here, so this is x squared. 3 times 6 is going to be 18. X times x is x squared. 3 times minus 6 is a minus 18. X times nothing times 1 is just going to be x. This 1 times 6x is just going to be 6x. This last one is going to be a minus 6. Okay? So you can see I've got all of these terms all multiplied out and all simplified. Now, notice this right here and this right here. These are like terms, so I can combine them. Okay? Because they have the same variable with the same exponent, these two things can be combined. So let's go ahead and rewrite that first term and combine the coefficients. So minus 24 plus 18 is going to be a minus 6 x squared. Now I do this piece. Minus 18 plus 6 is going to be a minus 12. I have an x here. And then lastly, my minus 6 comes along for the ride. Okay, so that is all. That's all for that question. We still have a few more. I just want to go through. This next one is going to be. It's going to be a fun one. Let me just tell you. I'm not really sure why I put this one in the homework, but I just thought it was fun. You'll notice that you're more likely to make a mistake. If you make a mistake early on, I'm just going to be honest, you're probably going to get the whole thing wrong. So just do your very best and try to make sure that your multiplication and adding is all done you're doing it correctly, that you're not dropping minus signs or positive signs. Usually that's the biggest issue. All right, so this question says 2x plus 5 times x minus 1 times 3x plus 2. You're probably thinking, Rob, are you psychotic? Why do you want to give this to us? Maybe part of me is a little psychotic. I don't know. I haven't been tested. But all I know is that this is not as hard as it looks. Okay, it's just a lot of writing is really all it is. It's a lot of basic adding and multiplying, but it's one of those things where you can get it wrong if you just make a simple mistake. So here's what we're going to do. We're going to FOIL the first piece, the first part. So we'll do first, outside, inside, last. So FOIL. So let's do the first. We're only going to look at these two pieces here. Okay, the first two. This one we're just going to bring it down and deal with it later. So the first, 2x times x. That's done. Outside, 2x minus 1. Done. Times the inside, 5 times x. Okay. Done. Times the last, plus 5 times a minus 1 is a minus 5. Okay. And then we multiply that by 3x plus 2. Okay. Let's go ahead and simplify this stuff. This is going to be 2x squared. This is going to be a minus 2x plus 5x minus 5. And the 3x plus 2 is going to come along for the ride. So these are all equal, by the way. I just assume they're all equal, okay? If I don't put the equal sign, it's still assumed. So then we do 2x squared. This is going to be minus 2x plus 5x is a positive 3x minus 5. 3x plus 2. Now we're in the same situation we were as the last problem. Okay, so we just have to multiply all of these individual pieces times all of these individual pieces, which means that we are going to have 6 possible combinations. Did I make a mistake somewhere? I feel like I made a mistake somewhere. Did I make a mistake? I made a mistake in my notes, but I'm doing it correctly here, so just bear that in mind. I don't know why I made that mistake. It was a silly mistake. Okay, sorry. I'm looking at my notes, and if you read my notes and you're like getting to 58 and you're like, dude, that's not the same. Yes, I understand that. I made a mistake in the notes. It's online. Okay, so anyway, there you go. So we are going to do 2x squared times 3x. Okay, so that times that. Then we do that times that, which is going to be, oh, remember I got to save space. 2x squared times 2 plus 3x. Now we're jumping to the second piece. 3x times this guy, 3x, plus 3x times 2, plus, I'm going to run out of space. I'm not happy. Plus a minus 5 times a 3x, plus, just pretend this is on the same line, minus 5 times positive 2. Okay, lots of stuff there. Okay, so now let's work it out. 2 times 3 is going to be 6. Here, let me try to be a little bit tighter because we still have to simplify and combine everything. 6, x squared times x is x to the third. Now 2 times 2 is going to be 4. X squared times nothing is just x squared. 3 times 3 is 9. X times x is x to the fourth. Where am I getting that from? Holy cow. All right, x squared plus 3x times 2 is going to be 3 times 2 is 6. X is just going to follow along. Minus 5 times 3 is minus 15. X right there. And then I have a minus 10, which is minus 5 times 2. Okay. We're almost there. I told you this is a long one. 6x to the third. And now I'm going to combine my like terms, which is going to be this guy and this guy. 4x squared plus 9x, so I have 9, 10, 11, 12, 13. In case you're curious, yes, I still use my fingers. Sometimes I need my toes, but fingers usually suffice. 9 plus 4 is 13. Okay, 13x to the 2. 6x minus 15 is, what's the difference between that? 9? Yeah? That's going to be a minus 9 because the sign for the bigger thing is minus. So it's minus 9x. And then I've got a minus 10. And that is my final answer. Okay. Boom. Okay, now let's just do a couple of foils and then we will be done. Quick little comments. It's probably no surprise to you that I'm a little bit older, okay, than you guys are. So, what that means, though, and I had this revelation today, I'm just going to let you know, some of you have not seen certain movies that are just staples that you just need to see. It kind of blows my mind that there's movies that are just incredible, that you're like, oh, I've never heard of that movie. Like, okay, I might in these future videos start telling you, okay, here's a movie you need to put on your must-see list because there's a lot of really good ones. For example, I learned today that somebody in our class, not naming any names, has not seen The Matrix. Okay, you need to go see The Matrix. It's a staple movie for the late 90s, and it's an incredible, like, it completely redefined movie making, how they do certain film and shots, and it's very philosophical, and it's just a very good movie. uh, you have to go see it. Okay, so Redbox it, Netflix if it's on there, Hulu. I don't care. You have to go watch The Matrix if you haven't seen it. Okay, that is your assignment. Due at the very end of this class. I will not pass you. I'm just kidding. Of course, this is like I'm being a little hyperbolic here. Okay, of course I will pass you if you perform and do the grades well. But it's super important, okay? You have to go see certain movies, like The Matrix. You have to go see it, okay? Done. I'm done. Question number 64. We are going to FOIL x plus 3, x plus 4, okay? So we do the first times the outside, times the inside, times the last. Again, we're taking all the combinations and then multiplying them all together. So here we get x squared because we have x times x, so that's x squared. So that's the first. The outside is going to be x times 4, which is 4x. The inside, which is 3 times x. And then the last, which is 3 times 4. 3 times 4 is 12. So now this is the same thing as x squared. I can combine these middle terms together, and I get plus 7x plus 12. Okay. 78 minus 7x minus 1, 7x plus 3. Okay, now again, here is, let me write out FOIL and then we'll go piece by piece. So first, outside, inside, last. First, minus 7 times a 7x. Let me just write it out. Minus 7x times 7x. I'll write it out for you so you can see it. There's the first. The outside is going to be a minus 7x times a 3. There's that. The inside, minus 1 times a 7x, which is a inside. And the last, which is minus 1 times a positive 3. Okay? And so now I have minus 7 times 7 is minus 49. X times x is x squared. Minus 7 times 3 is a minus 21. X comes along for the ride. Minus 1 times 7 is a minus 7 times x. And then I have minus 1 times 3, which is a minus 3. Okay? We're almost done. I just have to combine these terms here. And again, of course, I ran out of space. So I'm going to move it up here and erase this guy. Minus 21 minus 7 is going to be, well, let's first write the first piece. Minus 49x squared. Minus 21 minus 7 is a minus 28x. And then this is going to be my last piece right there. All right, well, that is all I have for multiplication of polynomials. If you have any questions, please do not hesitate to let me know. I hope you have a fantastic day. And watch some movies from the 90s, okay? Just throwing that out there. All right, have a good one.